Hello viewers, in this video we will learn the process of conducting a site suitability study for a potential landfill site in a city area in Bangladesh. We will consider several criteria including road distance, river proximity, distance from residential areas, slope and land use and land cover. You may also include additional criteria for your study. So first is river. It is advisable to avoid locating landfills near rivers to minimize the risk of water pollution. The suitability ranking will range from 1 to 5, where 1 represents not suitable and 5 represent highly suitable based on distance from the river, shorter to longer distance. And second one is road distance. A moderate distance to roads ensure efficient waste disposal operations, environmental sustainability, and cost effectiveness, while avoiding public disturbance from odor and health impacts. And if we can see residential area, so distance from residential areas, landfills should be located at a considerable distance from residential areas to minimize health impacts, nuisance caused by odors, pest, and noise related to waste disposal operations. Shorter distance, closer distance from residential areas are less suitable, while greater distance is increases the suitability ranking from 1 to 5. Highly suitable for greater distance from residential area, so I will rank it 5. And land use and land cover. Existing land use is a crucial consideration, as certain land uses may be incompatible with landfill operations. Landfills should avoid areas with ecologically sensitive land uses, proximity to water bodies, and housing areas to prevent contamination or habitat destruction. So in this case, for settlement, I will rank it 1, not suitable. Agricultural land, moderately suitable. Barren land, highly suitable. I will rank it 5. Vegetation, less suitable, and outer body, not suitable. So 1. Then if we go to slope, the slope of the land, the slope of the land affects drainage patterns and landfill stability. Ideally, landfill sites should have minimal slope to prevent erosion, waste runoff, and potential soil instability. The appropriate slope of potential landfill sites should be about 8 to 12%. So here 0 to 2, I have ranked 2 less suitable, 2 to 8 highly suitable, 5 8 to 15 suitable, and 15 to 13 moderately, and greater than 30 not suitable for slope. Uh, so by evaluating and analyzing this criteria collectively, a site suitability study can help identify areas that are more suitable for establishing a landfill site while minimizing potential environmental, social, and health impacts. Anyway, let's practice together. You can see over here study area shapefile, river shapefile, road shapefile, land use and land cover map, which I already have prepared, and gem. So first we will create distance from streams, distance from river. So here is the stream river shapefile. We will go to search box and write buffer. You will find here several options. Click on multiple ring buffer, add streams shapefile and distances. So I will add 200 meters, 400, then 800, 12,000, and 15,000, 200 to 15,000. And then buffer unit meter, and then click OK. Multiple ring buffer according to my assigned distance has been done. Now go to geoprocessing for clipping purpose. Clip and then stream multiple buffer, I mean the output file, and then clip area will be your study area shape file according to your AOI, area of interest. And then I will convert this polygon file into raster, as I need a raster file for the processing. Go to conversion tools to raster, polygon to raster, input features, add the last output, and then click OK. So here is our distance from a river. We have done on criteria distance from river. I'm renaming it distance from river. Now I will do for river, I mean road. Here is my road shape file for my study area, and then go to again search box, buffer, multiple ring buffer, add road as input features, and then as I have already showed this, and then write here distance in here, distance 200 meter, 500 meter, 1000 meters, 15,000 meter, and buffer unit will be meters. Then click OK, or you can go to environments for processing extent to select processing extent, same as layer AOI, area of interest. Mask layer will be AOI. Then click OK. Multiple ring buffer for road distance has been done. Now I will clip as per my AOI. Input features, and then clip features will be AOI, and then click OK. So it has been done for road. It is polygon file, so I have to convert it into the raster file. For that, go to Arc toolbox and again go to conversion tools and then polygon to raster. Add the input features and then click OK. So we have got road distance, I mean distance from road. Yep, you can rename it. So I'm renaming it our distance from road. So we have distance from road, distance from river. Then you can see land use and land cover map. I have already prepared land use and land cover map. If we yep, so I will extract residential area, I mean built up area, from my land use and cover map. For that I have selected only residential area, I mean built up area, from my LULC map, and I will extract from conversion tools, raster to polygon. I have input feature LULC, and then You can see here built up area has been extracted from LULC. As I'm going to prepare residential area, I mean distance from residential area. For that I will need this residential area shapefile. So you can see here residential area. Now I will perform again multiple ring buffer. Input features will be the, yes, this file, and then distances. You can see your residential area. I already mentioned shorter distance, longer distance, rank 1 to 5. So first I will add 200, and then 400, then 800, then 12,000s, and 15,000s. And buffer units as usual, meters. Then click OK. Yep, multiple ring buffer for residential areas has been done. Now geoprocessing, clip input features, then clip features will be area of interest, then click OK. Now yep, now I will delete the necessary file. Yeah, this is polygon file, so I will convert it into raster file. From raster to raster, polygon to raster, input features, and then click OK. Yeah, you can see here residential areas, I mean distance from residential areas has been also done. You can rename it. Residential areas. Yeah, we have now residential area, distance from road, distance from river, and also land use land cover map. And you can see here our we have DEM data from study area. Now I will perform slope analysis from this DEM. So go to surface tool and slope, input raster, DEM, and then click OK. And I will classify into 5 classes. And then we'll reclassify from search box. Just write reclassify, and then you will find this tool reclassify spatial analyzed, and from here just input raster slope, and then you can add new values onto 5. Output raster, you can save your output raster. So I'm deleting the necessary file, and you can rename it slope. So I have slope, residential area, distance from road, distance from river, and also land use and land cover map. You can also add additional criteria as per your study area, as per your requirement. Now you can see here land use and land cover map that I have been prepared already. So if you want to learn how to prepare a land use and land cover map, just go to my channel and go to search box, write LULC, and you will find several tutorials regarding land use and land cover map preparation using ArcGIS, NV, and other software. So you can easily prepare this land use and land cover map to follow my tutorial. Anyway, now I will perform weighted overlay. Just go to Spatial Analyze tools and then weighted overlay. Yeah, overlay, weighted overlay. Just add input raster, all raster. You have to input here first, slope and then residential area. Okay, and then land use and land cover. Okay, and then distance from road and distance from river. Then click OK. So now I will input here scale value that I have already described in the uh, yeah, scale value. I will first slope 0 to 2, I mean less suitable, then 2 to 8 high suitable, and then 8 to 15 suitable, 15 to 13 moderately suitable, greater than 30 not suitable. So first value will be 2, mean less suitable, 0 to 2, and then this will be 5 to 8 highly suitable. 5, fixed this scale value as per the ranking. 5, yep. And then residential area, 4 classes, shorter distance to longer distance. Shorter distance, closer distance is not suitable to highly suitable. So 1 to 5. Yeah, it is already in order. 1 to 4 for 4 classes. And then land use and land cover. As I have already mentioned here, for settlement, it will be not suitable. I mean, rank 1 for agricultural land, it will be moderately suitable. 3, so it will be 1, 3, 1. Then for 3, then 5, 5. It is barren land, highly suitable, and then yep, 5 for barren land, and then vegetation less suitable, and then water body not suitable. 2, 1. And distance from road, for distance from road, yeah, moderately distance from road is highly suitable. So 0 to 200 not suitable, 200 to 500 distance moderately suitable, 500 to 1000 highly suitable. 3, and 500 to 1000 highly suitable. It will be 5. And then distance from river, yeah, 1 to 5, I mean shorter distance to longer distance, shorter distance not suitable. So it is already in order 1 to 5. After assigning scale values to all criteria, we need to determine the percentage of influence. Each criteria is assigned a percentage of influence based on its relative importance in the analysis. The percentages represent the weight or significance of each criteria in the final result. This percentage determine how much each criteria contributes to the overall analysis and are typically assigned based on field surveys, stakeholder consultations, expert opinions, literature reviews, and so on. The total percentage of influence will sum up to 100%. Here I have given 30% for slope, 20% for residential area, 15% for LULC, 15% for road, and 20% for river as percentage of influence based on my field survey, expert opinions, and literature review. Additionally, it is important to ensure that the spatial resolution for each raster file must be same. I hope you found this video enjoyable. Thank you for watching.